All right, we got section 7.3, similar triangles. Angle-angle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if, for example, in triangle toe, we have an angle that is one arc and another that's two arcs, and then in triangle jam, we have an angle that's two arcs and one arc and another that's two arcs. Notice how those two are the same and those two are the same. So if two angles of one triangle are congruent to two angles of another triangle, that's what we have in our picture. Our conclusion is these are similar triangles. To remind you what similar means, this implies then that the third angles are congruent. So angle E is congruent to angle M. It also implies that the corresponding sides are proportional. Just reminding you what it means to be similar. Similarity comes from taking the preimage and dilating it, multiplying it by some scale factor to get to the image. Let's check out this next one. The SSS, or side-side-side similarity. If the measures of the corresponding sides of two triangles are proportional, then the triangles are similar. I may have misspoke on this previous one, I don't remember. But the corresponding sides are proportional. So this is saying that if you have this picture of two different triangles, and we know that corresponding sides are proportional, then we know that triangle toe is similar to triangle jam. This also implies, since they're similar, that the corresponding angles are congruent to each other. Just reminding you once again what it means to be similar. Third one, the side-angle-side similarity. If the measures of two sides of a triangle are proportional to the measures of two corresponding sides of another triangle. Well, let's figure that out first. So that would be like saying TO over JA is equal to OE over its corresponding side AM. And the included angles are congruent. Well, if we're talking about these sides matching up and these sides matching up, then the included angle would be angle O and angle A. This is the side-angle-side similarity. Then our conclusion, triangle toe, is similar to triangle jam. Now that implies, once again, since they're similar, that angle T is congruent to angle J, angle O is congruent to angle A, angle E is congruent to angle M. It also implies that this proportion that we had up here is equivalent to the last two pair of corresponding sides written as a ratio. Roger that. Roger that. Next we have this similarity of triangles is reflexive, symmetric, and transitive. This is the third, might be the fourth occurrence of reflexive, symmetric, and transitive. With numbers, so in the properties of equality that we did before, properties of equality for real numbers, the reflexive property was for all numbers a equals a. Every number equals itself. For the symmetric property, it had to do with an equation. If a equals b, then b equals a. The transitive property of equality for real numbers said if a equals b and b equals c, then we can conclude that a is equal to c. So similarity of triangles, similarity is replacing equality. Triangles is replacing numbers. So for the reflexive property, I need to think of a triangle. You can name any triangle you want. I'm going to name triangle hot. It's going to be similar to itself. Every triangle is similar to itself. Corresponding sides are going to be proportional. The proportion is going to be 1. Corresponding angles are going to be congruent. Symmetry. Symmetric. This involves two triangles. If triangle hot is similar to triangle meow, then triangle meow is similar to triangle hot. Transitive. This involves three triangles. If triangle woof is similar to triangle meow and triangle meow is similar to triangle then triangle woof is similar to triangle. Get it? Got it? Good. Check out an example. Determine if each pair of triangles is similar. If similar, state the reason and find the missing measure. We got three things to do here, y'all. Well, check this out. This angle right here and this angle right here, those are vertical angles. Vertical angle theorem says they're congruent. There is no way for us to know anything about these angles. So we can't use the angle-angle similarity. Since we have two sides and included angle in each of these triangles, we can try and see if we can use the side-angle-side similarity. For the side-angle-side similarity to work, we're going to compare 2 to one of these two sides. Now, which side are we going to compare it to? Well, if we go back and look at the two sides we have in this triangle, we got a 2 and a 3. Which one's smaller? Obviously a 2. So we want to compare that to the smaller side in the other triangle, which would be a 4. So for these to be similar, 2 is to 4 has to be the same as 3 is to 6. Let's see if that's true. 2 over 4 reduces to 1/2. 3 over 6 also reduces to 1/2. So the first part, determine if they are similar. So I'm going to say yes, they are similar. If similar, state the reason. This is true by the SAS similarity. Side, angle, side. Then it says find the missing measure. For this, Don't be arrogant. You hear me? Redraw one of the pictures so that the corresponding parts line up. If you don't do that, you are cruising for a bruising. 2 corresponded to 4, 3 corresponded to 6. That means x corresponds to 9. So make a proportion just like we've done many times in the other sections. Take 2 corresponding parts, such as 6 and 3. 6 is to 3 as 9 is to x. You can reduce your fraction first, or you can choose not to. It's your choice. I'm going to reduce it. 6 over 3 is 2. If I multiply both sides by x, on the right, multiplying something by its multiplicative inverse cancels. So we end up with 2x is 9. Therefore, x is 9 halves. Just going to double check to make sure I answered all the questions. Determine if they are similar. If they are, state the reason. Find the missing measure. I did all 3 things. Yay! Number 2. In the figure, segment ST is parallel to segment PR. So we show they're parallel. Before I get into the rest of the details I'm given, let's determine if they're similar. If they're not similar, this is going to be probably not possible to do. I think you would agree that angle Q is congruent to itself. Bold statement. That's the reflexive property for similar angles. No, that's not true. That's the congruence of angles is reflexive. Since ST and PR are parallel, I'm just going to draw some auxiliary lines here. QP ends up being a transversal. Corresponding angles are congruent when you have parallel lines. That's the corresponding angles postulate. For a similar reason, we could say that these angles are congruent because of the corresponding angles postulate. Now we've just given more reason than we need to show that these 2 triangles are congruent, that they're similar. We just need 2 angles. We actually showed all 3. So let me add the information to the picture, and then I'm going to redraw these so I can do this much easier. QS is 3. SP is 1. TR is 1.2. We're supposed to find QT. Well, here's a cutie right here. Adorable. Let's redraw this picture to avoid distractions. I'm going to get rid of everything extra and just draw this. We got Q, S, T, smiley face, frowny face, 1 arc. 3, QT. We know nothing about the bottom side. Now I'm going to draw this big triangle. So we got Q, P, R, frowny face, smiley face, 1 arc. We don't know the length of the bottom side PR. We do know the length of this side. It's QT plus 1.2. We know the side that's length QP. It's 3 plus 1, which is 4. Now, since these are similar, we should be able to make a proportion. 3 is to 4, as QT is to QT plus 1.2. QT is just a variable. If you're more comfortable replacing it with an x, that's cool. But at the end of the problem, you got to replace the x with QT because there's no x in the original problem. I want to get rid of my fractions. I'm going to multiply both sides by my denominators. Multiplication property of equality says if you do it to one side, you must do it to both sides. And when I say both sides, what I really mean is each term. On the left, multiplying and dividing by 4 cancels. On the right, multiplying and dividing by qt plus 1.2 cancels. So we end up with 3 times the sum of qt and 1.2 and 4 times qt. We distribute the 3 using the distributive property of equality. And then if we subtract 3 qt's from both sides using the subtraction property of equality, we get that qt is 3.6. Let's do another. If TS is 6, QP is 4, RS is x plus 1, and RQ is 3x minus 4. Find the value of x. We got to first determine how these little fellows are similar. Check it out. Vertical angles are congruent. We have another theorem that says all right angles are congruent. We got a right angle here, we got a right angle here. So these two triangles are similar by the angle-angle similarity. I'm going to redraw this triangle down here so that I'm 100% sure how my corresponding parts match up. We got a 90 here, we got a 1 arc here. The 90 was S, the 1 arc was R, the unmarked angle was T. Translate the information. TS is 6, SR is x plus 1. Since these are similar, corresponding sides are proportional. 4 is to 6 as 3x minus 4 is to x plus 1. Okay, reduce my fraction first. I'm not going to do that this time. Feeling kind of rebellious. Multiplication property of equality says that I can multiply every term in my equation by the same thing. I'm going to multiply by my denominators. 6 divided by 6 cancels. X plus 1 divided by x plus 1 cancels. We end up with 4 times the sum of x and 1, and 6 times the difference of 3x and 4. If I distribute the 4, I get 4x plus 4. Distribute the 6, I get 18x minus 24. Then if I were to, I don't know, subtract 4 from both sides, and then subtract 18x from both sides, then divide both sides by negative 14, I get x is 2. Before I get too carried away, let's make sure I answered the question. Find the value of x. Did it? This next one, boy, this one here is a bit of a stinker. Identify the similar triangles in each figure. Explain your answer. First of all, let's make sure we see all the triangles. There's this little fella. There's this medium-sized lady. And there's this ginormous other. There are 3 triangles. How many of those are similar to each other? Well, let's mark the angles. This is going to sound nuts, but angle A is congruent to itself. This is going to sound more nuts. Angle C is congruent to itself. Just when you thought we were getting really, really crazy. If this angle is 90 degrees right here, that means this is also 90 degrees because they're a linear pair, which means they're supplementary. Since they're a linear pair and they're supplementary, they have to be 180. If one's 90, you have to add 90 to 90 to get 180. I'm going to replace that 90 with the box just so you can see all this jazz. So what does that tell us? Well, check this out. In this little triangle, there is a 90-degree angle and a 2 arc. just going to redraw that triangle over here. I'm going to specifically redraw it so that my 90 is here and my 2 arcs is here. My 2 arcs was C, my 90 was D, the leftover angle was B. That, if you look at this big triangle, it has a 90-degree angle and a 2 arc. This has a 90-degree angle and a 2 arc. That means those two triangles are similar. Triangle ABC is similar to triangle BDC. Why? By the angle-angle similarity. Let's see what else we can do. If I focus now on this little fella, and I redraw it, and I redraw it so that I got 90 degrees in the bottom right and 1 arc in the top. The 1 arc is A, the 90 is D, and the angle I don't know is B. That makes that similar to this triangle. See it? Because we got 1 arc and 90 degrees. So I could say that triangle ADB is similar to triangle ABC. Why? Angle similarity. Now, if you haven't figured this out by now, triangle ADB is similar to ABC. Triangle ABC is similar to triangle BDC. The transitive similarity of triangles is transitive tells us then that triangle ADB is similar to triangle BDC. That is by the transitive property of similar triangles. You could also say because similarity of triangles is transitive. Now the reason that should make sense, if we go back to these pictures that we drew, if you know 2 angles of a triangle are congruent to 2 angles of another triangle, then the third angles have to be the same. Another way to think of it, if the 2 triangles are similar, corresponding angles have to be the same. And by that token, that makes this down here a 2 arc. That concludes the notes. Please do the 7.3 homework. I believe there's 2 assignments. You are doing the first assignment. Thank you very much.